Hey folks, welcome to another episode of ASP.NET Core from Zero to Overkill. In this episode, we'll start like a mini series inside the series about making better use of the type system. And in this case, we'll start with trying to avoid nulls to represent the absence of a value, and instead we'll create a type to represent that. In this case, we'll call it optional, but it's sometimes also known as maybe or option, and it's a kind of it's a type and a pattern that's more used in functional languages, but there's nothing saying that we shouldn't use it. And in fact, it's probably a good idea to use it in a language like C#, which isn't really functional, but has some functional features. So we'll try to play around with this concept in this episode. So for the plan, as I mentioned, we're going to try to express this absence of value by using an optional type. And the steps we'll take are to create a simple implementation. There are NuGet packages already existent that we could use to do this, but instead let's do a simple implementation for us to see how things work. It's not very hard, at least for this simple implementation. Maybe something more complex would be much more work, but we're going to keep it simple. Then we'll see how we can and should use it and expose in the APIs we have, the public APIs of our classes and all of that. And then we'll see a couple of examples of using it. So we'll use it in a more imperative way, which is common way we C# developers are used. So it's more do this, do that, then do this, then do that. And afterwards we'll see it more in a functional way, like it's used in the functional languages, and more like a declarative way, much like link. And we'll take just a final look at C#8, which introduced the nullable reference types. So I'm not going into much detail, but just give my 2 cents regarding this new feature and how it impacts doing something with the optional type. Before starting, the usual plugs. If the videos are being useful, please consider dropping a like, sharing them, and leaving feedback. All of them are important, but probably the third is the most one. And for more things, remember that all the videos of this series have a corresponding blog post on my blog. For more info, you can reach out through Twitter. And also, I've been sometimes, not in the past couple of weeks, but I've been streaming on Twitch as I prepare these episodes. So these episodes will hopefully become smaller, and then for more detail you can just check out the stream on Twitch, or if you can't see it live, I put the archive in YouTube. And if these contacts are not enough, you can visit the blog or my personal site, and I have other contacts in there. With this out of the way, let's get to code. So let me just go back here and let's start. And just before starting with the implementation, just a quick recap of why am I going to do this. So the problem with nulls, and I'm pretty sure many of us have already have this problem, is that it's easy to forget to check, and besides that, we end up with the code littered with if null, if null, if null. But I think the worst part is really we can forget it, and then in production we get a null reference exception, and we have no idea where, and it's one of the worst things to figure out what is the problem. So the idea of using a type, such as the optional type, to express the lack of value is exactly this, to make it explicit when we are getting something that it may or may not exist. So We could, for instance, using EF core, when we find by ID and we get the value, but it might be null, but we don't know that it might be null just by looking at the signature of the method. If instead it returned an optional of such entity, for instance a group, now in that case we would know, okay, this might not find anything, so we must prepare for that. So that's probably the biggest problem of null. It's not explicit, it can just pop up from anywhere unexpected. So by using something like the optional type, we make it explicit that this may or may not exist. So as soon as you see that in a method signature or in a property or wherever, you can think, okay, maybe this isn't present, I need to make code to take that into consideration. So that's the point we're going to try to work with. So we'll start by implementing this type. So let's go here, and over here in domain I created a shared folder where I put the optional type. It probably should be in another project because this isn't really part of the domain. It's something very generic that can be used in a lot of places. Maybe in the future I'll extract this, maybe put in a shared project to share as a NuGet package, but for now, for simplicity, I just created it here in another folder. So you have some things over here, but start with the optional implementation. So the first thing we can see is that it's a struct. This is for two main reasons. The first one is for performance, although I didn't really do benchmarks, so I may be wrong. But in this case, the idea is that considering that the optional type will simply be a wrapper around the actual type that we want. For instance, if we want a group, we just want an option of a group, so it's just wrapping that up. So instead of allocating every time two objects on the heap, we just allocate the group if it exists, and if it does, we put it inside an optional that simply has two fields, the value itself and a boolean indicating if there is value or not. So it should be, in terms of allocation, memory allocation and performance, because it's a small struct, it shouldn't be a problem because it's just a pointer to some value and a boolean. The pointer, if I'm not mistaken, are just 4 bytes. I may be confusing something, but my idea is that the pointer is just 4 bytes, so it's not a heavy structure, so copying it should be better than always allocating more objects. Besides that, being a struct has also an interesting effect for this case, that it can't be null. So it would be annoying if we needed to check if an optional could be null to then check if the value is in there. So we should assume that the optional is never null, even if we use the class. But in this case, by using a struct, we are sure that it cannot be null, because the struct cannot be null. So as I mentioned, we have just a couple of fields, one to indicate if there is some value and another with the value should it exist. There's this, I created this property, although as you see it's not really being used, but it's just to simplify. If in some cases we just want to know if there's a value or not, we can use this property. The constructor is the simplest thing that can be. The only thing we do is get the parameters and set the fields with them, and the constructor is internal because we shouldn't use it directly. We will use some helper methods, some helper factory methods to create instances of optional. And then the only method that's here is a try get value. And if you might notice that this follows that pattern that we usually see in things like a parsing, like a integer parsing or double parsing, which returns a bool indicating if there is a value, and if there is, the out parameter will be set with a value. So the idea here, this is very much on purpose, is that the only way to get the value out of the optional type is through this method. Because if we just expose this value directly, we would end up in the same situation that someone could just have an optional instance and do dot value and then get an exception. It might not be the no reference exception, probably would be an invalid operation exception because you can't access something that isn't there, but it would be an exception nonetheless. So by having a single way to expose the value, we make sure that the user has to consider the implications in case where there is no value. So that's it for this implementation. Really simple, maybe not the best. There are other packages like I mentioned. You should probably investigate those, but this is a nice base, I think, and we can achieve a lot with just this simple implementation. As for those helper methods I mentioned, there is here this static class, also named optional, and exposes some helper methods. There's a sum method, which we should use when we want to create an optional instance with a value. So it's sum, and we pass in the value, and it just creates an instance of optional, passes in the value, and passes as value as true. Then we have another helper method, none, which will create an empty optional of this type. So we'll just pass in the default and pass in false. So these are the base ones. Then, as I was noticing they could be useful, I added a couple other methods, which are from nullable, and also from nullable in this case is for nullables like int nullable, and in this case is for the typical classes that can be null. So this is just an helper for situations where we can transform something that we know might be null in an optional, and we'll see an example in a bit. So, but these are extras. Normally these kind of methods you'll see in most implementations of the optional or maybes. These ones are just me coming up with things. So this is, I guess, a simple implementation that should hopefully do the work. So, okay, this moved. Okay, so simple implementation done. So let's see how to use this to adapt our public-facing APIs to using it. So as you might remember, I'm not really using like a repository pattern, but I'm using something like that. So in the data, we have the queries, and for instance, user by ID query. And we want to find the user, given the ID, but it might not exist. So I changed this, which would just return user, to return an optional user. This is one such case. So it becomes clear by the interface that it might not be a user, so we cannot forget to check for null. It's explicit. It might be a user or maybe no user. Another example, if we go to our use cases, for instance, get user group, we go here, query, exactly the same. So we want to get a group for user, but maybe it doesn't exist, so optional. Again, explicit, maybe there's a group, maybe not. So this is usage on the APIs. Now let's actually see it in use in an imperative way. Before that, we'll probably take a quick look at that from Nullable where I'm using it, but we'll just go right into the implementation. So let's see. So for this get user group detail, if I'm not mistaken, let me see. No, that's not it. Where did I use it? Where did I use it in that way? I think it was here, exactly. This is an example where I did this imperatively. So let's start with the implementation of this one. So this is a user group query handler. So in this case, we're doing an EF query, which is huge because I have the code very zoomed in. But basically, as you can see, because this is a single or default and might return null, I wrapped it in an optional from Nullable. Just instead of doing an if null in here and returning some or none, just an helper method to avoid doing this everywhere. So in this case, it can return an optional of group. And then we will use it over here in the handle method of the update group details. So as you see, in this case, it no longer returns a group, but an optional of group. So that's the reason I called the variable maybe group, because maybe there's a group, maybe not. And like I mentioned, imperatively with ifs. So the code will be very similar to if there was a null check, but in the place where there was a null check, now there's this try get value to actually get the group if there is a group. If there is no group, I'm returning an optional of none, which is to say try to update a group that doesn't exist, so it will be a 404. So doing this, but again, this is in the, if we add the check for null, the code will be the same, but checking for null. That's when comparing the imperative way. When using this, it's the same as with the null, but the difference is that we couldn't really use it, because if we just did maybe group dot something, we don't have the group, we have the maybe, so we can't access things. So we are protected against no reference exceptions in this case. So if we continue the code, we have the same situation for the user. Maybe there's a user, maybe not. If we go to the implementation, user by ID, the same thing. I used the from Nullable again because maybe there's no user. And in this case, again, I used the try get value and try to get the current user. If not, throwing an exception in this case. In the future we'll change this, but right now there's an exception. We want to update a group, but we don't have a valid user. And you'll see that this try get value in this implementation that I made is the thing that we use all the time when we do this the imperative way, or when we implement helper methods for a more functional approach. So this try get value is the base for everything that we use, because the type is so simple. Of course, we need to use something. But then done. So now that we have the user and the group correctly, we can finally run the code. So group.rename and repository to update stuff. And to finish up, we want to return optional sum, because in the beginning we returned none when the group wasn't found. Now that the group was found and we could do the work, we can return sum with the information about the updated group. So this is an example of using the optional in an imperative way. So the code is the same as it was before, but now if we tried to use the maybe group in here we get an exception because it's not a group. So that's, even though this may not be as clean as if it was a functional approach, and functional programmer looking at this would probably be annoyed because we are using an optional, but then we are doing ifs the same way as we always were. Yeah, I understand their point, but even this way it's better than getting a null reference exception when we least expect. So might not be the prettiest, but it's better. So we've seen an imperative usage. So what would be a functional usage? So a more declarative usage of this. So as it is, we can't, because we just have this try get value, which is far from declarative. So I created some extensions, and you can think about these as link. So we have the base in the optional, and then we can create a bunch of extension methods to let us use to do things more in a more declarative way. So I can just show you, I created a bunch of methods and most of them are used, so I'll just show a couple of them. For example, feel free to check out the code and see, probably there's things that need improvements, but so a simple one is the map. So basically it will map if there is a value, so always react on a maybe value, and in this case if there is a value we want to map it, so ignore the guard clause that should always be there. But then basically we're using the try get value. If there is a value we return an optional sum with the mapped value. If not, we just propagate the none. In this case, if t out is different from t in, we are just saying that it's a value that's absent, but it's just a different type. So we end up, it's kind of mapping things. If it's the same, it's basically the same optional. Another thing we could use is value war, not being used, but basically is if there is a value, we'll return it. It's an alternative way to, instead of using try get value, is we get the value if there is. If not, we use a factory. Map value or is similar to this one. Is like a mix between the first and the second. If there is a value, we map it using the function. If there isn't, we call the other function that is put in there. Let's go down, there's a bunch of them, so I'll just look at another one that we are using, which is the match sum async. And as I was preparing to record the episode, I remember that I can do some things to improve these methods, but let's go with them as they are. So basically it matches when there is something. So this is a func just because of the task, otherwise it could be an action. So we have a maybe value, and if there is a value we call the function that was passed in. If there isn't a value, it's a no op, and we can go on. So as you see, these are very simple things that we can easily do in the code, the calling code, but it just might make that code cleaner if we have these helper methods to avoid spread this everywhere. So now let's see some of these in actions. Let's see the map. Map is used once in this query handler. So in this case, we have the maybe group, and we are using the map just to, instead of doing an if and trying to get the value, and if there is a value we map, otherwise in the else we return an optional of none. Instead, well, we use the map. If there is a value, it will map. If there isn't, it will propagate the absence of value and we can just return it. So makes the code simpler and more declarative. Like when we use link. When we use link, we could do the same with for each and fors and stuff like that, but the code just gets a little bit cleaner when we use that in that way. So it's the same logic when doing this. Instead of writing the same code all over the place, we have some helper methods that clean up things. So let's go back to the over here. Value R we don't use, but we have a couple of usage of a map value R. So in the groups controller is a good place. So what we are doing here is we do the operation using mediator and we get user group query, and what we do is map value R, and I just need to put this explicitly here. I think the main problem is this action result, because it's a weird class. It's nice, but kind of weird because it implicitly converts into the value into an OK, or we can use the action result, so a bit weird. So we needed to use this. But besides that, what I'm doing is, if there is a value, I'm just returning the value. No need to map anything, but if we wanted to map to a different representation for the API, we could do it here. If there is no value, we call the not found to return a not found result. So again, we could do an if or use a ternary operator, but we could also do this. And ignoring this part, that's not great. This part ends up being nice and clean. So map value R. The other thing that we have here, the match sum async, is used in the delete, and basically we are getting the group. Maybe it exists. If it exists, we want to delete it. Whoops. What is going on? So if the group exists, we want to delete it. Otherwise, we can just return. Again, we could just do an if, try get value, all of that stuff. But instead, again, we just use this function and say, if there is something, do it. Otherwise, let it go. So again, simplifying things. And in these examples, because it's pretty simple, the ifs and the ternaries would just work just fine. But if we think in some cases like we do in link, where we chain various methods together, you can see how this could be useful. For instance, we could even, this match sum async could be chained here directly. I needed to do some adjustments because of tasks and stuff, but that's an idea for next episodes. And we could chain these calls together. And for people who've used Angular in the front end with RxJS, it's basically the same thing, where we do those maps, flat maps and all of that, where we chain together methods. It would be the same logic. In this case, it's simple, so maybe I'm not providing the best examples to illustrate how useful this could be, but hopefully it's clear enough how this works, and at a glance, thinking about link and stuff like that, how this could be useful in other more complex scenarios. So right now, just to wrap up, a quick mention to C#8 nullable reference types. Let me just get the link over here. I forgot to open the browser this time. Or better yet, let's go here. So C#8 brought with it nullable reference types, and the idea is to help and inform that something might be null. So as we have the the value types that can be null by using that question mark, the int question mark or double question mark. The idea is using those question marks in other classes, with other classes as well. So with this, I had a comment in YouTube asking what I thought if these nullable reference types would make using an optional unneeded. And to be honest, I don't know. But for my opinion, at least for now, no. For a couple of reasons. For starters, I'll just drop the main reasons why I don't think they completely replace, at least at the moment. The first one is that these nullable reference types in C# will just provide a warning, not an error. So if we don't do what the compiler warns us, we can continue. Maybe this is a moot point because we can configure the build to treat those warnings as errors, but don't know. For instance, Kotlin, it is a compiler error if we try to use a possibly null value without checking. So I would prefer that, but for this case and the other that I will talk about, I understand why they did it this way, because it would be too much disruption to do such changes, but at the same time it feels like it doesn't fulfill its potential, but we'll see. So for the second reason why I'm not completely convinced is that to use this, all the libraries, all the dependencies must embrace it. So if a dependency that we have doesn't use annotations or use the question marks in the correct places, and we don't know that it might be null, our application will just assume it is safe. So I would prefer the other way around. For again, using Kotlin as an example, things that come from Java to Kotlin, they're assumed to be unsafe and can be null. So we must check. In C# they did it the other way around. If we have no information, it's not null because we don't. It's probably safe. So I would prefer the other way around. But again, I understand why they did it, because if they did it this way, as soon as we turned on nullable reference types, all our code would be warnings because we don't know. So I understand why they did it, but not a fan. Maybe in the future. So even right now, if we go to, there's a post by Matt Storgensen, which is C# lead, where he talks about, why is this not black? My eyes. But he talks about the adoption phase. Let me see. Somewhere around this post, he mentions that this is the Nullable rollout phase. Yes. So he says that between the introduction with C#8 and .NET Core 3 and until .NET 5, which is by the end of this year, calls it this Nullable rollout phase, where the libraries and all of that should be including this. Although probably not all of them will do it, but let's assume so. So when we have all of this, if this Nullable rollout phase goes as expected, maybe, and if we, for instance, went to the compiler and set the option to treat these warnings as errors, maybe in this case the optional would be less useful. I still think it could be useful, for instance, for using it in that more functional way. But for the basic part, we're checking the null, maybe this will be enough for a lot. It certainly will be good. Might not be great, but will be good. And then we think about the code that cannot be updated as fast and all of that. And those are some of the reasons why libraries take longer to update, because not all clients will be able to update with it. So yeah, so let's see. Hopefully this will be as useful as they expect. But if not, and in the meantime, we have a type system that we can use. Maybe it's not the strongest when comparing to other languages, but it's stronger than what we use on the day-to-day. So let's try to use it. And about this, it's all done. So if you want more details about these things I'm working on, remember I'm doing stuff on Twitch, so these videos hopefully are getting smaller. Probably not this one, but hopefully the videos of the series are getting smaller. For more info, visit Twitch or visit the recordings afterwards that I put on YouTube. And that's it for this episode. Hope to see you in the next one. See yous!